Welcome. In this video, we will look at solving quadratic equations with the quadratic formula. In class, I will be proving where the quadratic formula arrives from, but in this video, just more how to use it. The premise is an if-then statement, and here it goes. The quadratic formula states that if you have an equation of this form, ax squared plus bx plus c equals 0, so if that's big if, it has to have all the elements. You must have an x squared term, and it needs to be probably in that order and definitely set equal to 0. Then here are the solutions to the equation. The x values will be equal to the opposite of the b coefficient plus or minus the square root of the quantity b squared minus 4 times a times c, or 4ac, all of that divided by 2a. Yep, it's a little bit of a mouthful. We're going to be using that. It's not as bad as it looks. We're just going to be identifying A, B, and C, kind of plugging into the formula and getting the solutions. Again, where did this come from is quite interesting. Please come to class to see that. Let's take a look at our first example. We're going to be solving the quadratic equation 3x squared minus 14x minus 5 equals 0. You can see that this equation satisfies the if. It is in the right order. It is set equal to 0, so we can identify our A, B, C. A is 3. All right, I'll just kind of highlight there. B is negative 14. Please use the sign in front, and C will be negative 5. Those will be my A, my B, and my C. So when I plug into the equation, x is equal to all of that. I recommend using parentheses. The first part is negative b. I'll just put a set of parentheses for b, plus or minus big square root b squared, again, parentheses, minus 4 times a times c. And all of this is going to be divided by 2 times a. All right. Don't put the a in there. All right, just put the value. All right, so now we're going to plug in all the numbers. So a is 3. It's going to go in 2 locations, here and here. B is negative 14. It's going to also go in 2 locations, there and there. And then lastly, C only goes in 1 location, here. That's the answers. Those are the solutions, but I want you to simplify that and make it as easy to read as possible. So we've got to be careful with the order of operations. All right, so cleaning up this problem a little bit, first place to start is out in front here. We have minus negative 14 or negative 14. That will become positive 14. Plus or minus. Inside the square root is typically where you have to, where we have the most issues. Following the order of operations, right? We're using our PEMDAS. So inside that square root, the first thing will be an exponent, negative 14 squared, negative 14 times negative 14, positive 196. The next thing oft missed here is that you have to subtract all 3 of these multiplied together, and that's because multiplication comes next in the order of operations before addition and subtraction. So I'm going to take my, either a calculator, or you can do it in your head here. The numbers are small. 4 times 3 is 12, times negative 5 is negative 60. And so that's minus, and again, that's the minus sign from up here, and that's going to be negative 60, all divided by 2 times 3, 6. So cleaning that up even a little bit more, 14 plus or minus, you can see here we have 196 minus a negative is like adding. So I'm going to take 196 plus 60, and I get 256 all over 6. Now, in this particular example, turns out our square root has a nice whole number answer. The square root of 256 happens to be 16. So when this is the case, you actually have more work rather than less, but you have very nice solutions. So I would like you to evaluate that as either x equals 14 plus 16 over 6, or x equals 14 minus 16 over 6. Simplifying those as much as possible. The first one, 14 plus 16 is 30, divided by 6 is 5. The second one, 14 take away 16 is negative 2, divided by 6. This, I'll write that down. That's negative 2 over 6. If you divide by 2 over 2, you can get negative 1/3 as your simplified answer. So we have 2 nice rational solutions. Let's take a look at an example where we don't have these last few steps and it remains irrational. We still want to simplify it. All right, I'm going to put my next example in here, nestle it below it so that you can still see the formula. So here's the equation. I'm going to solve the equation negative 3x plus 5x squared equals 17. In this particular case, the if part of the statement is not satisfied. We need the equation set equal to 0. Deleted that there, set equal to 0. So your first step would be to reorder these terms and subtract 17 to get a 0. So I'm going to subtract 17 from both sides of this equation. When I do that, that will eliminate, and I will get the 0 that's required for the if statement. On the left-hand side, none of these terms are like terms, but you want to order them. Put the 5x squared term first, then the minus 3x, and lastly, minus 17. So in this case, we have an a of 5, a b of -3, and a c of -17. Plugging into the quadratic equation, we get x equals negative b. I'm just going to plug it in as I go. That's -3 plus or minus the square root of b squared. B is, again, -3 minus 4 times a. A is 5, and c is -17. All of this will be divided by 2 times a being 5. Oh, we've got quite a bit of simplification we can do here. Let's see what happens. Again, with the order of operations, we're going to first flip the sign there in the front. We're going to get x equals +3, plus or minus. Inside this square root, be sure to do the squaring first. -3 squared is 9. Again, we have minus. In this case, we're going to figure out 4 times 5 times -17. I'm going to use a calculator for this. And let's see, I got 20 times 17 is 340. So that's -340. All right. All over 2 times 5, or 10. Moving along, let's see. That's going to act like 9 plus 340, so that will be 349. Now, you can try that on your calculator, but I do believe you're going to get an irrational number. I don't believe that the square root of 349 is going to yield us anything useful. It is a decimal. The other thing to check is what the factors of 349 might be, and well, it won't matter much here because 10 only has factors of 2 and 5, and that one certainly does not. So that is actually a nice simplified answer. We really can't do much more than that, other than if you wanted to make a list, and it's still important to know that, hey, that's 2 solutions. Okay, so what does that mean? It means that one of the solutions is 3 plus the square root of 349 divided by 10, and the other solution is 3 minus the square root of 349 over 10. Those are our 2 solutions. We'll look at many other examples in class, so be sure to be there. I hope this helps you get started on solving with the quadratic formula.